one, and go.
Welcome to yet another episode of Indigenization Appreciation Hour. My name is Saurav Jha, and with me is my long term associate, Sriram Tyagarajan. So, today we are going to be talking about India's homegrown unmanned combat aerial vehicle program, once upon a time known as the Ghatak program, but not anymore, as I keep stressing through various episodes. Yeah, let's just call it the IUCAV program. Okay, that is what it is now, I guess. So this IUCAP program is promising. Let me say at the outset that it is quite promising. But obviously, there are a number of questions that typically crop up when you talk about, introducing an stealthy unmanned aircraft, which will which will sort of occupy a niche that has previously been, served by manned aircraft. And also there is this question of just how capable you want your system to be, and at what cost will you get that capability. Because you see, when these systems first entered the fray, and and they entered the fray decades ago, actually, because the old, or or I think many of you might be aware of all the old American programs like the X-45, etc. And then of course there were, that was part of JUCAS. Then you had other programs succeeding it, and you had precursors to those programs going back into the 90s. So there was a time when people thought that the 2020s would see, these sort of unmanned combat aerial vehicles, this typical stealthy flying wing, tailless flying wing kind of design, basically be replace a large part of the manned feat. The idea was that the projections at that time were, I'm talking about the late 90s, early 2000s, that such designs, such unmanned stealthy designs, would end up replacing a large part of the would have ended up replacing a large part of the manned combat fleet of the 2020s. But that has not been the case. As you can see, combat fleets are actually being recapitalized across the board, and there is talk of expansion in all the major air forces in the world. Not just talk. In the case of the Americans and the Chinese, they are actually recapitalizing their fleets compared to, say, the 2010s, right? So we are seeing that there is that manned that new, very large purchases of new manned fighter jets are on the anvil for most major air forces. So then the question arises, and so then we come to the issue of, so what happened then? Why is it that that so-called promised land did not materialize, or has not materialized yet? So that is definitely a question, and we are going to try and answer that question in the course of this program, because that has a direct bearing on, what kind of a role the our own proposed UCAP program can play. And so the question is that whether a unmanned stealthy tailless design of the X-45, X-47, and our own proposed IUCAP variety, can it really, be a force multiplier? Can it make up, in our specific case, can it help us make up for the shortfall in squadron strength as far as manned fighters are concerned? And a very important and relevant question: the sum total of its costs, how will that compare with the cost of inducting new manned fighters? Okay, so these are three very important questions. These are three very important issues that we need to address. Now, broadly speaking, I can say something. When you talk about an unmanned stealthy combat aircraft or combat aerial vehicle of the variety we are talking about, the first thing is that it's usually made up of composite material, right? That requires specific tooling, manufacturing capabilities. And of course, then there are other then it'll have specialized materials anyway, of the, radar absorbent materials, and it'll have specialized structures as well, radar absorbent structures. But that would be the case with a fifth generation manned fighter as well. But a fifth generation mine fighter would be more titanium heavy than a UCAV of this variety would be. Such a UCAV usually is built with a composite body, right? Because you want to make the most of the tailless design, and the fact that you don't have a large RCS cockpit. Because see, in a man fighter, the cockpit contributes a large to a large fraction of the radar to the of the radar return, right? The radar cross section of the aircraft from the frontal hemisphere. So the point is that, so you want to make you want to take full advantage of all that, but of course, like I said, all this requires specialized materials, advanced tooling. Fortunately, in India's case, because of the LCA program, because of the LCA design, which essentially is covered in composites. I mean, 90% of its surface area is composites. T300 carbon prepegs are used. And it is 40% composite structures by weight as well. We have credible capability for this part of the equation already, and we have mature capability, right? And we have the tooling already in place. So that is one box ticked. Having said that, on the other hand, you will also have to pay an unmanned tax, right? While when you talk about a stealthy unmanned combat aerial vehicle, when proponents talk about it, they will talk about the fact, that it doesn't require a pilot, which means that it does not require expensive displays. It does not require expensive life support systems like an onboard oxygen generating system. It does not require an ejection seat, obviously. It does not require certain kinds of control systems also. Not certain kinds, cockpit controls it does not require of the same kind. So all of
Displays.
those things, yeah, exactly, displays I said. And especially today, smart multifunctional displays, which are very expensive. So you take all those out of the equation, but at the same time, there's an unmanned tax. Even as you displace the manned tax, there is an unmanned tax that you have to take into account. You see, because you need very hardened and capable communication systems and data links, and you also need AI based, AI relevant processing capability, onboard processing capability, right? And you also need a certain kind of high fidelity sensor mix. Of course, it can be argued that many of these elements now you need on the aircraft of today as well, because this notion that that you just have a manned fighter and that can obviate the need for very advanced navigation or onboard computing is no longer that valid anymore. But we'll come to that. But and of course, you definitely will need a superior guidance package, say in the form of an inertial navigation system, than you have on a manned fighter. Okay, you'll need something that you'll need the kind of, I'll give an example. You'll need the kind of mirror based ring laser gyroscopes that you might be putting on some strategic missile system. So those are the and even better systems maybe. So all those things are, have to be taken into account. Then there is the larger question of, the laws of physics itself. If you want an unmanned system to be exactly like a manned system in terms of its capability set, okay, one thing you can knock off. If you want that stealthiness, then you won't get the maneuverability of a fighter with, vertical stabilizers with vertical tails. You won't get it. So, but everything else in terms of air to ground, air to air capability, then the size and the materials used on board may not be that different. Okay, of course they could be different. I talked about how the composite percentage will be much greater in the case of the stealthy unmanned fighter. So then where will the cost savings be? But then this ultimately misses the point. Say the IUCAV, I don't think we're trying to create a stealthy unmanned light combat aircraft with the IUCAV. I think we are trying to create something which will be stealthy, which will be survivable, but at the same time, it may not have the entire capability set of a 4.5 generation fighter, but it'll have something else. It'll be able to penetrate, very dense air defense networks. It'll also be able to stay silent. Okay, but then we come to the next question: how silent will it really stay? Okay, because when Bombay doors open, because this thing will have an internal weapons bay, right? It'll be the weapons will be carried internally. When the internal weapons bay open, obviously the RCS spikes. Second, if it's going to use its own sensors, then that is another point of insecurity that could be exploited by the enemy. Third, if it's not using its own sensors and it's only going to take very silent shots, the fact is then it'll have to receive information from somewhere else, right? So that also means that there are downlinks involved, or there are data links involved, satellite downlinks or data links, which could also be discovered by the enemy. So all these questions are, have to be sort of examined very closely and have to be modeled. But I think they have been modeled, because we are now progressing with this. We are going forward with this program by all accounts. I mean, EOI for DCPPs are going to be our development cum production partners. The defense acquisition procedure of the Ministry of Defense now allows DRDO and the DPSUs to choose private sector DCPPs, who are development cum production partners, who are there from the involved from the prototyping stage, and on the completion of successful prototyping are likely to get orders for serial production. And the fact that that CCS proposal is going to be moved suggests that these questions have been answered. The answer is in the positive, or rather the answer is a yes to the kind of value this particular design might bring. So with that, I'm now going to turn to Sriram, and he can share his thoughts. Over to you, Sriram.
Yeah. So when we talk about unmanned platforms per se, right? So the whole point is, why are we doing it? And not just for the heck of it. So the question is, what is the ultimate goal, or what role is an unmanned platform of any size going to do as part of your force structure, and what is the end goal that you're trying to achieve? So design of these unmanned platforms will derive from the operational role, or in broad terms, that such platforms or the Air Force itself wants to achieve, and that will determine the platforms. And it is not just that, obviously, but whatever technologies we've already matured, and whatever will mature in the next, say, 5, 10, 20 years from now on, for any country doing this development, right? So there are obviously countries who have a very long history of aircraft development. So they have their own ideas, and we've learned quite a bit and created quite a bit of infrastructure, be it talent or physical infrastructure, with respect to manufacturing aircraft, like Saurav was talking about, right, with respect to the LCA program itself. So the question then is, what can we do, and what is the world around us doing when it comes to these things? So everybody now is of the opinion that China seems to be the 21st century's Russia, right? So the threat posed by them is nearly 100 fighter aircraft per year production rate, and their massive investment, be it in the breadth of unmanned platforms, all the way from very slow UAVs all the way to rocket propelled hypersonic UAVs like the D-21, but these are rocket propelled, right? So their attempts span a very wide range. As to their effectiveness, we still have very little combat experience to learn from.
Yeah.
Sorry?
WZ-8.
DR-8. So as far as combat effectiveness and the effectiveness of the platform itself is something that we've not seen, because they've not been battle tested, right? The oft quoted term. So given that, what is the threat against which all of these other countries are looking to generate programs to fight in, say, another 10, 15 years, or maybe even lesser than that? So we've also talked about the new large fighters that they've shown, right, in the last 1.5 years, be it the J-36 or the J-30, whatever the nomenclature is, right? So from each of their fighter aircraft companies. So now the question is, they seem to be at least posturing that they can put up a large number of aircraft in the air to fight your own aircraft, or for long-range strikes against distant targets. Their primary aim is to tackle the US Navy and US Air Force, as well as the Japanese and the Koreans on their eastern side. And whatever capabilities developed there obviously is relevant to us also, because a lot of their air bases on the southern side of Tibet are very close, but they also have air bases curving northward through Rumchi and Baingolin and all of those other strategic air bases and ICBM silos and everywhere, which is where the H6 fleets are based. And given the size of these new fighters, they can be placed there also, and we could be seeing long range strikes from there, be it against our fighters or targets on the ground. So this is the sort of threat that we are seeing, right? So the ask out of any such unmanned fleet will be to provide mass for us, because even in the best case scenario, in the next 10 years, we're not going to significantly increase our fighter numbers. Could we see a faster route towards higher number of aircraft in the air through unmanned platforms, even if they are say 30% of the capability that we're looking for? Quantity is its own quality. So perhaps we could do that, because Saurav was talking about the UCAV program, the bigger 13-ton bird, which is primarily strike oriented. But we also have the CATS program, which has its own variety of unmanned platforms going forward. We now have the almost 2-ton CATS Warrior, which is being powered by the PTAE-7 modified version. 2 of them, right? So we also know that the CATS Warrior program itself has plans for significantly heavier platform, which will be powered by something of the Manik thrust class, or maybe even in the future when the HTFE matures, we might see something that is powered by that. KDE produces 51 kilonewtons of thrust, max dry thrust, right? So 25 tons is like half of that. So you could have 8 or 9-ton bird being propelled by that, and you could have a tree type structure which can fly along with manned platforms, directed by manned platforms, but performing all of these roles. And the question which is natural is to ask if any of these smaller birds can hang around with a manned bird and provide the same range with whatever limited payload that each of them have, as good as say an LCA Mark 1A or an LCA Mark 2, right? A twin seat, for instance. It does. See, people have to realize that not all of them are going to take off from the same runway, so they don't need to have the same range payload capability. So we can work on a distributed mode, because nobody's going to base all assets in one place. So people have to think about, when we're talking about large systems, people have to think that all of them will be disaggregated physically, and they will team up, right? So that level of thinking has to be thought of. I mean, I'm sure the IAF already knows, because they already do all of these things. Next question is with respect to how do you network all of these, right? So when you talk about networking, that is a major challenge, because when we talk about a manned platform leading a bunch of unmanned platforms, each of them should have enough autonomy, just like technology readiness levels have, all the way from 1 to say 10 or something. Autonomy also has a similar chart, right, where levels of autonomy are broadly defined. So we're not quite yet there where we can tell a particular platform that you can go and work autonomously and come back. It might work for a cruise missile, where you program waypoints, program the target, and it's a one-way mission. But the cruise missile has only one role, right? Take off from one place, then go hit a target.
Yeah.
But a UAV might have multiple missions, and should be able to follow a particular a decision tree.
Yeah, but there's a A to this. There's a counter to this argument, because almost 20 years ago, Boeing and DARPA with the X-45 had demonstrated that 2 of them could work essentially autonomously and even prosecute pop-up threats, and that was 20 years ago. Okay, that was way before the GPU era really came in or anything. So this is a matter of this view is actually contested now, the kind of autonomy that you can have. Anyway, continue.
Yeah. Like the previous image showed, you have all of these assets already in place, and you would have the Airbus guys have done a really good job of putting this up. Anyway, let's stop this. Right. So you have all of these assets that have to work together, and see, having them work with each other is fine, but when you're talking about different sizes with different levels of responsibility and ability to switch roles or missions on the fly, either autonomously or when directed. So there's a lot of work that still needs to be done to have enough confidence in pushing them out and into battle, right? So the whole computational power that is required on board, as well as networking ability between local as well as semi-local and all the way up to the manned platform. All of these need to be done, looked at, and ability to survive against offensive capabilities in the electronic domain also need to be looked at, right? So all of these need to be planned, because you will encounter unknown threats and unknown ways of combating your systems, right? So it's not just another guy with a gun. So all of these need to be planned, catered to, and rigorously iterated to get to some level of confidence where these can be put into place. And the reason these are important is because you cannot import such systems, right? So you could probably import a fighter and tweak its usage to something that it was not designed for by the designer country, but such systems are entire black boxes, right? So it's very difficult to understand how they work and how they will function given a new threat. So unfortunately or fortunately, these systems have to be developed by us to truly understand what goes inside and how these individual systems think and how they think together as a group. So we're not talking about how the radar of each thing will work, or how the EO system of each thing will work, or how the EW system of each thing will work, right? So when you're talking about such bigger systems of connected nodes, then it becomes a lot more complex, right? The complexity grows by magnitudes. So the people who have to sit and think up architectures for these things have to be really good. So then it comes down to creating new brain trusts and recruiting particularly for these. One sec, I think my camera's full.
Yeah. So
Yeah.
the
Yeah. So all of these are yeah. Go ahead.
See, the point is, what you're making is right. The point you're making is a very crucial one. It's a crucial point. Because of the complexity, the chances of AI misbehavior are also very high. Okay, AI misbehavior, because when, as you mentioned, when you're talking about combat, real time combat, you're talking about several unknown unknowns. Known unknowns are there, but there are several unknown unknowns as well, and then that could lead to fleet wide grounding because of one glitch that shows up in the AI software, and that will obviously entail costs and stuff like that. When you're talking, especially when you're talking about a swarm, but what which is why I want to bring the conversation back to the kind of stealthy unmanned
Yeah.
UCAV, that we are talking about. Because look, as we know, training on the edge hasn't been achieved by anybody yet. People are looking at neuromorphic approaches rather. They're not you looking at a neural network approach anymore. So that's another conversation. We'll have that in the future. But the point is that a UCAV like this, coming back to a question like a UCAV like this, why has there been institutional resistance? Now, institutional resistance is not based, derivative of just some bias, some man fighter bias, or some people perceiving the threat of replacement. It is ultimately usually a reflection of very real world, hesitations and limitations that people may have seen in the course of the development of such systems. But those are being addressed. For instance, it is usually argued that this does not really lead to any real substitution of manpower requirements, any reduction in manpower requirements, because you need very trained personnel on the ground. You need people for, mission planning, launch, recovery, maintenance, highly specialized people. You will also require your own kind of training regimen and maintenance regimen for this sort of system, which will have to be developed on the fly actually as you adopt such systems, and that will entail costs. So these arguments are there, and these are not invalid arguments, but things are changing. For instance, today, one such UCAV is not going to be controlled by one ground station only. Okay, and now the ability is there for 10 of these UCAVs to be controlled by a single AVAX in the air also. And no real great retraining will be required for mission operators over there. So that sort of possibility is there. Then you have, launch recovery operations have got much more automated now. India has also, with the Swift, with the feeder project, the, stealthy, let's put up a photo of that, the famous Swift project of India, right?
Yeah.
The Swift demonstrator has already proven a lot of things. Okay, and that has made a huge difference. I mean, stuff like automated launch and recovery, waypoint navigation, maybe even being able to sense pop-up threats, although obviously the Swift was not weaponized or anything, but might be in the future, we don't know. In fact, weaponizing the Swift and creating a swarm of that might be another interim way to go forward, right? So all of that has been proven in India, right? It's not like we are behind in that realm, and it's a matter of debate. Like, you're very right about levels of autonomy. So the real question with those levels of autonomy now is the cost associated with achieving each level of autonomy, right? So if you have the collaborative combat aircraft that we are talking about, those are essentially, like, they are all ultimately born of that DARPA long shot program. The idea is to extend the range of your air to air missiles, or air to ground systems, where you
Yeah.
have something flying stealthily up ahead or in some other quadrant, and you send a command to it and it launches a package. Okay, that sort of thing. So those will have to be attritable. Unfortunately, what has been found, those are also not proving to be as cheap as people thought they would be. So, what the point I'm trying to make is, if the Ghatak can come in at the cost of a LCA Mark 1A, okay, with all of its ground strike capabilities, of its strike capabilities, I would be all right with it, because
Mm.
it will be highly survivable and it will be able to penetrate enemy airspace. But all those and as you were mentioning, it is time to do this anyway, because there will come a time when all the usual constraints have been overcome, right? And that is the time when you have to be ready with your doctrine, with your structures, with your training and maintenance paradigms that are relevant to such systems. So this UCAV is also going to be part of a learning process, and that learning process itself is going to have strategic effects in the future. Now the question is that, what about our more immediate concerns? What is our most immediate concerns? Dwindling, fighter squadron numbers, which are now going to go down to 29 till the new LCA Mark 1A unit start going to the field, to the respective air bases, and then new raisings will again happen, and we'll again start regaining squadron strength. And we may, if the government opens its purse strings, I would volunteer that we can regain our squadron strength by, attain that 42 squadron mark by 2036 itself, provided various things go to plan. Of course, that is also subject to the American engines, coming on time. And that engine part will come to why this UCAV is, as you mentioned, the KDE program is also being progressed. So why the UCAV program is very important for our engine development efforts as well. I'll come to that in a bit. But the point is that you can develop, given the success of the Swift, given the success of the Swift, and the fact that you have proved that kind of tailless, vertical stabilizer less flying wing design, right? Of course, scaling up does have some challenges, but I think the control laws can be tweaked by us, because we are quite capable in that area, thanks to the American sanctions post 1998. So we have cracked that code already. And so the this program is de-risked to a great extent if we have very clear cut and very, what should I say, realistic targets, as far as its capability set is concerned. realistic objectives as far as the capability set of this UCAV is concerned. We should focus on the strike element one, and we should focus on being able to hand off control and obviously you'll have to focus on emission control from the UCAV itself. I mean, see, there's always that temptation to make it more modular, to make it also an ISR kind of a proposition where it is a sensing node more than anything else. Does that? But I would say that given our current requirements, I think we should focus on it being more of a strike node. Now, somebody would argue, what is the point? We are in any case, we are making 800-kilometer range BrahMoses, and we are going to produce a lot of pralays. We are also entering the hypersonic strike age, both with hypersonic glide vehicles and soon with a scramjet powered hypersonic cruise missile itself. Now, what is the point of then this having another 50 or 60 million dollar a piece IUCAV, right? But the point is that yes, you can do all of those. Those will be launched by man fighters or from the ground, but this thing will also have persistence. See, the one thing that this thing will have, which will be better than an LCA, okay, will be persistence. In fact, I would say that if done right, and with the kind of Kaveri derivative engine we have now, this can end up being quite persistent, right? I won't go into exact figures. So that persistence will also give you a certain kind of flexibility, and it will also allow you to approach the enemy's air defenses from different paths, which simply using a manned fighter to launch from somewhere else or ground based launches will not give to you, right? I mean, that'll be traded off with range anyway if you try to do that. So this thing will give you that persistence. So I would say that if the capability set is kept rational, or is rationalized and is kept realistic, this has the potential to have real strategic effects, right? You were going to say something.
No, at least for us, right, in our context, we really shouldn't be looking at cost at all, because our immediate needs for the next 10, 15 years is quite drastic. So we should be able to say that we're going to bite the bullet, and we're going to achieve capability no matter how much it costs. Even if it costs the same as a manned platform, that really shouldn't matter to us. Yes, there is always the talk of we're making it in India, so it should be cheaper than any imported fighter, or license producing any imported fighter. If we do that for the same cost, we might get better capability. No, see, you're never in one single spot in time. You're always moving, right? So any capability or any capability being developed or executed today is a step towards creating capability for tomorrow. So the whole interim import has never worked over the past 5-6 decades, right? So, and the lesson is glaringly obvious. So even now, even if the platform that we developed is say 3/4 of the cost of a Mark 1A, it shouldn't deter us from pursuing that as an objective. Instead of just saying, okay, fine, we'll order 6 of these, but go and see if you can bring the cost down to 1/3 of a Mark 1A, right? So that kind of a mindset, the figures, I'm just throwing it out there, but I hope you get the point, right? So the whole point of cost reduction as an exercise should be looked at, but it shouldn't be a major aim of the program itself. I hope I'm putting it across.
But the point, the point you're making is well understood. But the point is that the cost matters because you can buy many more of these. Okay, that is the whole point, right? So if you have this coming in at 50 million and it works, I would say you buy at least 300 of these then. So because that's the kind that'll create the weight of attack that you want, and it'll allow you to hit and it'll free up your manned systems to do other things. Now again, there'll be another question. This will also this will have to work as part of a system of systems, right? So that also will give you opportunities for capability development, because the way to do it is, instead of having that expensive, today you can miniaturize that ground control system with limitations and put it on one of your existing fighters, especially if you have a two-seat fighter like the Sukhoi
Mm.
30 MKI. The weapon system operator can do that. That can work in concert with maybe one or two of these, okay? And that also will be a force multiplier, right? Instead of having one smaller RCS manned fighter work with an Su-30 MKI, you can have two of these working with an Su-30 MKI with a large ASA-based Virupaksha radar. Okay, so you can have that kind of a setup, and you can
So,
then even
yeah,
even with
go ahead.
proper, if you do enough work on the, now somebody say, but why do you need something like this? Well, then why not just XQ-58 Valkyrie quasi attritable kind of aircraft? Because those are not really stealthy, okay, and those have a lot of other problems. They don't, I really doubt how much value for money they are, okay, whereas everybody is jumping onto them. That cost equation is even more contestable than the cost equation for this IUCAV at the moment. I'm not dismissing them or denouncing those anyway. That approach needs to be pursued as well. That manned unmanned teaming approach with, that replicated approach where you have thousands of essentially
Loyal
Hellcats
wingman.
warriors. Yeah,
Yeah.
Hellcats warriors. Say, so in our case, that is what is the lead program, right? Or the Abhimanyu CCA from New Space. I'm not denouncing or detracting from that at all. I think that approach needs to be pursued. It's a valid way of looking at things. But this is a shorter way towards capability, because this thing is large enough to have a whole bunch of onboard systems, right? That 50 million has to be accounted for with something. Whereas in that, the paradigm is essentially completely AI and networking. That is the only paradigm going on over there.
No, it might not
In the
have
case of,
as many
yeah.
sensors as a 13-ton class bird, but it should have at least one.
And it'll have to have obviously onboard antennas for transmit and receive, right?
Correct.
So the cost picture is less clear over there. That's the point I'm trying to make. So we are
Ha!
getting there. We'll get there. I am a votary of having a small, turbojet powered stealthy kind of a what should I say, you've sought those conformal weapon pods, right? That Boeing developed for F-18. Now
Yeah.
imagine one of those with pop-out wings and a small turbojet carrying
Mm.
two air-to-air missiles. Okay,
Mm.
I'm even okay to exploring that
Yeah,
option as well.
essentially a wrapper for
Yeah,
air-to-air
yeah, yeah,
munitions.
yeah. An arrow shell basically. Okay, for two air-to-air missiles. I'm okay
No,
with that concept also.
no,
But
I get that point. My whole thing is those can be stealthy enough given their small size, right? So as long as you can figure out the whole structure of your force, you would need both, right? So your strike platform can do primarily strike, but there are other roles to be played. Like you said, transforming them into ISR platforms, probably doesn't make sense because you probably need something that is a lot faster to do ISR. If you want to send something that stealthy into contested airspace to do ISR, might as well send something that's a lot faster than something that flies at 0.8 Mach, right? So you're going to need an entirely different platform. Maybe something gets developed in the future, but the whole use case for something like the cat's warrior or any of the hunter or any other platform is attritability, which means it has to come in at a cost that you're willing to eat, right? So if it's 50 million, you're not going to eat that cost, right? You might write it off as the battle loss, right? So that is different, but you're not going to send hundreds of these and say, okay, I'm willing to accept 30%, 40% loss. But for something like the Cat's Warrior, you are essentially throwing hundreds of these into the air and hoping, with enough confidence that a solid majority of it sticks. So, assuming you put two air-to-air missiles in one warrior, right? Assume the bigger Cat's Warrior, the 10 or 15-ton class, maybe even 3 or 4, right? Now, depending on the weight configuration and the engine that's chosen. 4 of those, and you have multiples of those, and you can go to war. Just like the wall of F-15s was a concept. You can create a wall of unmanned fighters. You can have a flight of 4 manned fighters, and you can have 20 of these flying in front. to prosecute any J-36 that comes into the air. You can have a gigantic internal weapons bay with, say, 6+4 air-to-air missiles, but I can field 20 times 4. So,
Well, all that is yes, but all that is hypothetical. Having said that, a big shout out to the HAL Cats Warrior team and the Abhimanyu team at New Space. We are generally with you guys. Okay, we have your
yeah.
backs, if you like. We are not in any way detracting from what you're doing. We're fully supportive of it. Coming back to the IUCAV, the what do you call that? The IUCAV, as you mentioned, the whole issue of strategic effects. The strategic effects are not only limited to the actual prosecution of battle. Okay, the steady or the war or some future air war. The strategic effects are on the military industrial side. And one of the things that is happening via this program is the further development of the Kaveri derivative engine, right? Because money has been allocated for both creating a proper technology demonstrator and also for integrating it onto a platform, which is obviously going to be this platform only, the one we are talking about, right? So, because flying test bed tests and all that are happening in Russia. So, Kaveri derivative engine is not your grandfather's Kaveri engine, really. It is far more stealthy in terms of acoustic stealth and other aspects. Okay. So, concurrently with this UCAP program, and for once we have a working engine, an engine proven on the high altitude test facility, which we are going to now use on a platform, right? So we are not going the other way anymore. So what is going to happen is, I would say that there is going to be a Kaveri derivative engine 2, there will be a KDE 3, there will be other KDE follow-ons, okay, which will basically explore that paradigm. New materials will be used both to increase the stealth of the basic design and also to reduce weight, which will lead to thrust to weight ratio increments of their own. Whether they'll be that appreciable or not, we don't know, but a little bit might happen, right? So this program will also take forward your a certain kind of engine practice, engine design and development practice in India, which is very important, which will focus not on creating a variable cycle engine or creating something which has much greater thermal efficiency, has much better turbine entry temperatures, etc. This will much higher turbine entry temperatures. This will focus on something which is going to contribute in other ways, is going to show you how to make a gas turbine, an aviation gas turbine, a low bypass turbofan, stealthier. Because see, one of the big issues with any stealth aircraft is not just the frontal cross section, it's the cross section at the radar cross section at the rear. And for that, the engine and its engine's nozzle flaps all play a major role in that. Okay, so what materials you use, what do you do, how do you bring that down, how do you design the engine to make sure that it is sort of compatible with an overall stealthy design. All of those things are going to see a quantum jump in India via this program if it is pursued successfully. So this has all kinds of strategic effects. It'll help you create new doctrine for unmanned systems. It'll help you understand the training and maintenance cycle of such systems. It'll help you develop the hardened com links and hardened and develop the system of systems paradigm that you need. It'll help you with material development. It'll help you with the enhancing AI and autonomy on board flying platforms itself, which will help you with your future manned systems as well. Because all your manned systems are supposed to have AI co-pilots and stuff like that, right? They are going to be optionally manned in the future anyway. Any sixth generation fighter developed by India will be optionally manned. Actually, even the
Even the
AMCA
AMCA.
Mark II will be optionally manned. Exactly, the AMCA Mark II will be optionally manned, because see, there's no point having a pilot for ferry flights that the plane should be able to do on its own. So, ferry flights are a very important part of what the Air Force does. So,
Repositioning.
exactly, repositioning. Then there are many issues where you're going to exercise areas, so on and so forth. Training and Maintenance may be happening somewhere else for something specific, so on and so forth. So, all of those things mean that this particular IUCAP program has strategic effects that spans not only the strategy will have strategic effects not only on the battlefield, Okay, directly, but indirectly as well through a lot of second order effects. So in that sense, this is a critical program. This is a highly critical program for India, because and for once, see, I'll give you an example. It'll also stimulate the development of certain kinds of semiconductors also in India. See, right now, if you look at most of these sort of unmanned systems, even whether CC or not, I think many of them are using what is called the NVIDIA Jetson, right? The Jetson Odin probably.
For
Anyway,
compute on the
so
edge.
yeah. So stuff like that. You need insights into that as well, and you need to at some point develop hardened versions of such things and better versions. So this is a program that will that has so many capability, I mean technological capability sets associated with it, that it is in no way less important than, say, what the LCA was in the 1990s to the aerospace ecosystem itself. Yeah, you're saying something.
No, I mean, just to add, right? So, uh, the capabilities that you develop, especially on the backend side of things, are applicable across programs, right? So, whatever you learn from the IUCAV program can be ported over to the MUMT program, and whatever you learn from the MUMT programs, you can port over to the IUCAV program also. And Akshay had a question about strategic bomber, right? So that can happen. You could have a twin engine bomber in the future that is predominantly unmanned, right? And
Yeah,
just one
exactly.
person to do the push the button, right?
And we all
So
know who the person pushing the button will be, right?
no, I
You
hope
obviously,
nobody has to push
you're
any buttons.
you're the one who'll be pushing that button. Nah.
No, I'm saying, see, if you look at Able Archer style exercises, you had fleets of intercontinental bombers and multiple air crew, to do those nuclear missions. So you could have the flying part of it predominantly unmanned and somebody taking care of the weapons package alone. So assume you have two people, right, to have confirmation for strike, but the flying itself could be entirely unmanned, leaving the crew or decision makers to focus on their mission of side of things. So even for stuff like maritime reconnaissance, the MR role can also turn into a major unmanned role, right? We're buying MQ-9s. The MQ-9s that the Navy wants are for, persistent maritime reconnaissance. And the P8s, we've flocked the P8s. There was a CAG report or Defense Committee report which talked about how many hours of flight that our earlier Russian Tupolevs had done and how many hours our P8I fleets had done. And the difference was night and day. We were just doing so many more missions, so many more hours of flying across all over the IOR. And the Navy already has leased a couple of MQ-9s. So, and that's the progenitor to the whole MQ-930 of them being bought. And we see tremendous value in these assets for doing ISR roles. And we've seen from the past few years in all of these conflicts that non-stealthy ISR platforms have pretty much less than a day's life in contested airspace. Sure, during peacetime, yes, we can flog our tapas and whatever else gets built here, but battle time reconnaissance will need something that is stealthy, something that can survive, SAMs and Iglas being thrown at it,
So
and
then
at
we go
least
back to the
escape and
same
come back.
issue then. Then we
Sorry?
are back to the same issue. There will always be this temptation to turn this into an ISR platform
No,
as well,
the
in the name of
the
modularity.
UCAV need not be the ISR platform. I'm saying one of the CATS platforms can be. So even if you
Yeah,
lose
but will
them,
they
they
have
don't
the
really
persistence
matter.
that you need? There's a question of persistence. The persistence is always a question, right?
Hmm.
How much persistence are you going to get out of one of those attritable aircraft? Those are
Maybe
supposed to
something
be.
based on it, but smaller in size. Who knows?
Or larger in size, like the MQ-25.
Could be,
then
yeah. Again, that is
yeah.
another major question, because uh, you can't just rely on satellites alone. You need airborne surveillance anyway. So
No, I totally
that is
agree.
a
You
given.
100. That is an absolute given. You absolutely need
So
that.
like I
In
said,
fact,
you just have to spend. You cannot choose.
in fact, let me give a salute to the humble infantryman. You need boots on the ground as well with eyeball Mark 1. Okay,
Correct.
even in this day and age. So
Yeah. Even something like the Swift itself, it's one-ton bird, right? So to tack on some EO that is low profile, and even that can do, the ISR role. Maybe something bigger, maybe something that's 5 tons. Put an STFE variant on it and call it a day, maybe.
actually,
Right?
all the stuff that is being developed via Mumty can later be ported onto a Swift unmanned stealthy wingman. Okay, unmanned wingman, a loyal wingman, Swift can easily, two of those can easily fly with an AMCA, or maybe three of those if computing goes out. Because right now, what is the problem? The problem is that even with two pilots, nobody's really being able to control too many of these. Okay,
Yeah,
and this
you
notion,
come up on the human side of things being a
yeah,
problem.
and this notion that you will have a gaggle of them and all operating in concert with each other, you can do that with but that also makes them more visible on the battlefield. Okay, so there's a trade off over there as well. So there are these trade offs, there are some very real trade offs, as is the case with any element of warfare. So now let's just take a few questions and we'll have to bring this episode to a close, right? So
Onyx, let me just take this one, please.
yeah.
I've seen the questions on all of our IAHs. For now, we have no clarity on what kind of quantum well detectors we're going to use. So, if any of the kind folks at SSPL actually write another set of papers like they did a decade back, we might know what our IRFPs are based on. So until then, I'm as clueless as you when it comes to that question. Yeah, go ahead.
Yeah. So what another question Akshay Iyer has asked, of course, your favorite question, which you
Answered.
already talked about. Can IUCAV become our strategic bomber? No, but it can be a regional bomber. That is what I'm talking about. It can definitely be a regional bomber, and it'll be survivable as well because it'll be quite stealthy. I think it'll be in the VLO range. That is why it has. That is why development has also taken a long time. See, in any case, I'll tell you honestly, and a bunch of people in India will not like what I'm saying, maybe, or and probably the whole of Pakistan will not like not like what I'm saying. But by 2030s, Pakistan is not going to be in any kind of a position to fight with us. Okay, let me be very clear
Shouldn't.
about this.
Shouldn't.
Ah,
Hey,
eh,
to add to that
ah,
question, right? There's another thing that we need to think about. Uh, Everybody's benchmark is the B2. The B2 flies with 4 of those gigantic F110 drive versions, and it's got insane range.
F118,
118, huh?
F118, yeah.
And it's got insane range. It can strike in the Middle East and go back, with refueling. But that is the kind of range that the platform has, and it carries, tremendous amount of tremendous amount of payload, right? Something close to 18 tons, if I'm not wrong, but it is quite a bit. It's not, the 2 or 3 tons of manned fighter. So when we talk about a 13-ton platform for the IUCAV, to have, and we're not looking at an internal weapons bay which can carry, 10 tons or something. So that is like impossible. We're talking about 1.5 tons or something, right? So to have the persistence that we kept talking about, to go all the way to the north of Tarin Basin and come back, it will need to be pretty big to carry a lot of internal fuel, right? So those are considerations which will lead to size definition right at the outset when you start full-scale design. And that will have a major impact on cost. So the total amount of fuel plus payload will determine your size, and that will determine your cost. So depending on what your parameters are with respect to cost as well as range as well as payload, determines the size of the bird, and maintenance and lifestyle costs add up as your size goes up, right? So these are considerations that will need to be done And it's not just for the bigger platforms, even for something like the multi platforms, the same applies, because even if per platform the cost differences are not that great to look at it individually. When we're talking about the mass effect that we need to do, you have to multiply it by volume. It's like retail sales. The difference in cost might be very little, but if you shave off one paise on per unit, when you build thousands of it, it adds up. The same thing comes across, right? So the at the outside, what parameters are defined for design become extremely critical.
Yeah, see, because the that whole initial development phase, that is always critical. But the good thing is that pre-project activities for the IUCAV have been successfully completed, right? And that's why we are now going to see that CCS proposal being moved, and EOI for DCPP and all that came out in the public domain, as people know. So the point is that we are committed to this, and I think we need full commitment. We need to make this work, because that's going to give you an advantage. See, in this world, nobody can be the leader in every branch of technology, and that is a simple function of how much time has been apportioned, what kind of resources and time have been apportioned by credible groups in various countries to what. Okay, so there is always the question of, like, when if you go a step before design choices, there is the question of technology choice itself. What do you work on? Now, if because of the well known problems associated with these systems, which are essentially legacy problems, if there is institutional resistance to pouring resources into them, saying that, oh, this takes away from proven man fighter technology, then you will have a situation where somebody who does not have that constraint will go ahead in this area. Okay, but today you are in a unique situation where you are not going to be able to regain your man fighter strength quickly. All your man fighter, the recouping of your fighter strength, man fighter strength, and the recapitalization of your fleet is not front loaded at all. It's going to happen later. It's going to happen very quickly once you cross 2030 probably. But right now it's not going to happen that quickly, so you have a 5-year window of time when you can see if you can get this show running, because you already have had the swift and proven a lot of things via that. If this thing can enter production before 2030, I would say you have a strategic winner on your hands, right? So that is where, now, as far as this thing, like I said, this will be the regional bomber and everything. We'll take one last question and then we'll call it a night. Okay, somebody has said, any indigenization efforts for a 950 HP turboprop for Hail RPA? So, though we won't give you specifics, but in general, yes, because as you can see, I think Sriram wrote an article that we have on our website about the kind of movement that has been on the on this kind of propeller driven UAV power plant side. So most of the movement has been on piston engine systems, but as you know, NAL works a lot on propeller, on turboprops as well, and turboprops will be a natural outgrowth of our general jet engine programs, jet engine efforts. And a 950 HP turboprop should not be a big deal, because we are going to be looking at 5000 HP per turboprops for civil airliners in the 2030s. That's the kind of stuff we'll be looking at.
Yeah, if the RTA program ever gets off the ground, then we'll see a proper mission mode program for that.
Again, another one of those ifs. But a lot of things are getting off the ground. Okay. And of course, now somebody will call me a white pillar. And of course, you are the foil to that, and you're the quintessential black pillar. But but I'll tell you one thing. Okay. Like I said earlier, the Pakistanis are not going to be in a position to fight with us by 2030 or so. They also know that, which is why all the shenanigans are going to happen in the next 2 years. The so-called window of vulnerability and all that. And I can tell you one thing: when you have the kind of deep magazines that we are now becoming serious about, in terms of air launched supersonic weapons, ground launched supersonic weapons, ground launched quasi ballistic missiles, air launched quasi ballistic missiles, okay, and ISR network, and also if we do this UCAV, the Chinese will not want to engage with you either, because they'll not be able to win. You see, the question is being able to humiliate India in a short span of time. If they're not able to do that, because it won't be a short span of time, India will come back at them, and their bases will be taken out on the Tibetan plateau. Then it will be
Yeah.
a matter of their deep magazine versus our deep magazines. Okay, that is,
And
which is why production capability is
there's
so important. Ah,
there's one major thing to add on top of it. The Israel conflict has uh, reduced in tempo by a significant margin.
yeah, yeah,
So
absolutely.
so
But
we have one of our traditional sources going back online. So
no, traditional source number one is also going to be online soon. Okay,
yeah,
yeah,
if
and
that happens, then yes.
and
No, but
and
like Saurav said, we're getting self-sufficient in artillery and small arms munition. That was our major challenge earlier. That is no longer a challenge. And once the SAW and all the other PGMs get into series production, that will be another thing off our list. And air-launched missiles are coming. Once the Rudrams get certified, that is another line that will keep humming. So there'll be
much
enough.
more is coming. Hold on to your seats. Okay,
Yeah,
one
and
last
there are the
question.
fast movers coming in, so that will
Yeah.
also help.
So, Mr. AKA or Mr. Aka asks that, thank you for your contribution, first of all.
Yeah, thank
And
you.
please, I would request others to emulate him and also make contributions. You have the QR code in front of you. You can make contributions via YouTube directly as well. So,
Yeah.
anyway, the question is it in India's interest to help the US curb Pak ICBM program? Was Indian interception of the dual use missile tech for Pak in 2020 based on US intel? Well, let me say this: before the Americans showed their true colors, revealed their true colors, I would have said yes, we should have participated with them. But now, if Pakistan is so hell bent on an ICBM program, please be my guest. Okay. See, because see, what is the negative for us? Negative for us is if they have ICBMs, they can launch it on a depressed trajectory at our targets, or they can opt for a lofted trajectory also. But even with a depressed trajectory, I don't think that ICBM is going to be able to make it without having a lot of updated technology. Okay, and that updated technology will make its way to their IRBMs and MRBMs anyway. So the question is that the range of the system itself, does it give them any? Does that throw some new challenge for us? Very, very marginally, I would say. Right, that is not what we will be concerned about. At the same time, if they have a modern ICBM that can reach America, well, then that is something for America to think about, isn't it?
Pakistan, right? Once all of these unmanned systems go into production
Uh,
and we start inducting them, uh, Pakistan might not be able to afford the numbers if they want to buy such systems from Turkey, right? So the systems that Turkey is going to build is not going to be cheap, right? And Turkey isn't a China or a US to be able to grant in aid such systems in volume enough to create issues. And the whole point is mass. So none of this, single daytime raid with 100, aircraft in the air trying to knock off one or two Indian Air Force planes out of the air and claim victory, while all of their air bases from Gujarat all the way to Jammu and Kashmir are getting rogered, right?
so that
So
is the
that will
modus
not happen.
operandi. That is the modus operandi. The whole
Yeah,
idea
with
is
mass, that is unlikely to happen.
do a sneak attack, cause some damage on the Indian side, and then use the entire Western and Sino propaganda
Yeah.
machinery to take a dump on India.
Yeah,
Okay, you had
while
this
all of their bases
yeah.
get
Yeah,
hammered over the succeeding week.
see, and Air Force's bases are flattened, many of them effectively. The others are hit at very crucial points, right? At in areas of vulnerability. Their centers of gravity are prosecuted. Nobody sees that as a clear strategic defeat that it is, okay, of their Air Force on the ground itself. But what, two three fighters you lost on some aerial battle, that is like a, that is the real thing. You see, that is what has really happened. And everybody from the prime minister to the second division clerk, okay, in Yojana Bhavan
Has
must
to
resign.
answer.
So that is the this is not a way of doing things. Okay, it's okay, you guys win the propaganda war for as long as you like. We will create the country-sized magazine. We will launch all those 300 satellites into the sky. Okay, and we will have technologies like chemical vapor infiltration and electron beam physical vapor deposition. All of that we'll have, and you can keep crying about how backward we are, how we how inept we are. You can say whatever you want. I don't care.
Yeah, how
Okay, I
100 of
just
us
don't
are
care.
equivalent to
Ah,
one,
so
uniform
keep
jihadi.
saying all of that. Be my guest.
Yeah.
Anyway,
Hey,
with that,
Balakrishna Prabhu, thank you for your
yeah,
contribution. Please
yeah.
do
Shout out,
continue with
shout
the
out to
exercises.
Balkrishna Prabhu, who's by the way an inveterate supporter of DDR and indigenization. So we should generally appreciate him, in my view. Thank you for your
Yeah.
contribution. And he made a much bigger contribution, by the way, in a previous program. That was quite significant. Thank you for
Thank you.
that
Thank
again.
you.
Okay.
One last question and then we're done.
Yeah.
Master Chief asks, how quickly can we adapt the C295 for AUWNC, and what about the A400? Can we get that? A400, see, the IAF has an RFI out for a medium transport aircraft. So everything from the A400 down to AN21 is included in the weight class that they've put out. So maybe once that, acquisition program runs through, and whenever we finally end up getting a medium transport aircraft, the A400 is in the running, but I think it's too big. But yeah, as to the C295, we already have a plan, right? So CABS, the AVAX lab here in Bangalore, they have a plan for the maritime multi-mission aircraft, which will have pods on the side for maritime reconnaissance. We can put something on top, but the Air Force already has two programs running. One is the Netra Mark 1A, which is for 6 additional Embraer ERJ-145 based aircraft, similar to the 3 that they've already built, with newer technologies, better performance, all of that. And the other A320 class aircraft that DRDO got from Air India before it was sold to the Tatas, right? So that will be the bigger one with, again, balance beam from what I remember, but bigger array, greater performance, better range, and all of that, altitude capability also. So we are looking at 12 acquisitions, and I'm hearing that talks with Airbus for aircraft modification are finally getting close to agreement. So once the government gets that information formally, I think we'll see that getting sanctioned. I think for the Netra Mark 1A, we already have heard that Air Force has already identified sources for the ERGA 145s, because that
they are all
is out of
pre-owned.
production.
They're pre-owned. They're all pre-owned
Yeah.
aircraft.
So secondhand, if you want to call
pre-owned.
that, in automobile terms. So so those are also earmarked. So finding out new sources will not be an issue. Apparently, that's what we're hearing. So once sanctioned, the program should move quickly, and I mean, there is a massive urgency for both platforms. So it will happen. C295, I don't see us putting balance beam. The Pakistanis don't have money, so that's why they have the turboprop driven ADIs. We have a lot more money, so we can afford the
But
jets.
see, in the case of the Pakistanis, I won't worry about money because they can always get gifts from someone. Okay, so
Gifts, OnlyFans type gifts.
yeah. Well, question is that you don't play this kind of game where where they are in the air, you are in the air, they have a network environment, you have a network environment. You prosecute them properly and teach them a lesson, as simple as that. So that taking silent BVR shots, using the data link and having transmissions from
They
the
played their
ADI
hand.
or some ghost Chinese satellite will not work anymore. Okay, it's as
Yeah.
simple as that. So it's going to be very simple. The next time in the next round, please be ready to be plastered if you are the Pakistan Air Force. And this I'm not saying this in jest, by the way. So anyway,
One last thing. Onyx
Yeah.
Prime, we have posted pictures from Air India last year where they had electric actuators that will go on the AMCA and every other platform going forward, right? So this is from development from the missile program. Soumya De, I can't see your full name, sorry. Fortunately, I can't see your full name, but again, thank you for your contribution, generous. Looks like it's your first also. So yeah, thank you so much for your contributions. And again, to everybody else who's watching, please do contribute.
Yeah,
we're very, very gracious.
That's our first
Grateful
super
for-
chat, by
yeah.
the way. It's a watershed moment. Soumya Dev K's contribution is our first super chat ever.
Okay.
Super, yeah. First super on a live stream. We need many more of these. Keep it going, okay?
Yeah.
And we are going to bring you the latest analysis, obviously, on what is going on in these matters, so that you are up to date, basically, with the trends and the sort of the emerging complexity of warfare. Anyway, so now we are going to call it a night. As always, Jai Hind.
Thank you. Bye bye.